The next thing I want to talk about are tree diagrams. Here is an outline of what we're going to cover. A tree diagram helps us represent the various events and their associated probabilities. The various outcomes of each event are represented as branches emanating from a point, and each branch is labeled with the probability of its outcome. So here we have the first outcome is 0.5, second's 0.2, third is 0.3. Notice that these still add up to 1 because the probability of all possible outcomes is going to add up to 1. We can also have a tree diagram for multiple experiments. Okay, so here's our first experiment, here's our second experiment, and again we list the probability of each outcome occurring. So let's work through a simple example. I want my experiment to be tossing a coin 3 times. So I'm going to use a tree diagram to represent this experiment. So the first thing I do is I toss my coin, so I have an H or a T. The probability of getting heads is 0.5, the probability of getting tails is 0.5. Okay, let's toss our coin again. Again, I have the option of heads or tails, and again, the probability of each of those is 0.5, right? These are equally likely events, not super exciting. And again, heads or tails, heads or tails, heads or tails, heads or tails. I should have done something green. It would have looked more like a tree. Hindsight, right? Okay, so one thing that's really neat is then if we multiply down through the branches, right, I can get the probability of this event occurring. So if I want to know the probability of heads, 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 that's 0.5 times 0.5. The probability of this event is 0.125, right? That's the probability of each of these outcomes occurring, right? Like 1/8. So that's kind of interesting for us to know. It's really helpful, especially when the probabilities aren't equally likely. Which brings me to our harder example. So this is a medical example. So the reliability of a skin test for active pulmonary tuberculosis is as follows. I don't know if you guys had a TB test. I had to have 2 TB tests before I was allowed to come visit you guys. True story, and I have to do it every year. So the reliability of skin tests is actually for people who have TB, like if you actually have TB, 98% of them get a positive reaction. That means you get like a little welt on your arm, and 2% have a negative reaction. Okay? So that means that this test is only 98% effective. 2% of people who have TB, their test doesn't come up positive even though they have TB. For those who don't have tuberculosis, 99% will have a negative reaction, but 1% will have a positive reaction. When we talk more about statistics, or if you take statistics with me in the fall, this is what we call a false positive. This is a false negative. Okay, so from a large population of which 2 out of 10,000 persons have TB, a person is selected at random and given a skin test which turns out positive. What's the probability that the person has active tuberculosis? That's a lot of information. We got to break it down. So, I'm trying to find the probability that someone has tuberculosis given that their test was positive. Let's figure out some probabilities. So the probability that someone has tuberculosis is 2 out of 10,000. So that's 0.002. That means the probability of someone not having tuberculosis, right, or TB converse is 9,000 9,800 out of 10,000. So, sorry, 9,998. Oof. 9,998. So that'd be 0.9998. So that's a probability that someone in our group doesn't have tuberculosis. The probability that someone has a positive TB test and has TB is 98%. That's the probability that someone has a positive reaction and has tuberculosis, so that's 0.98. The probability that someone has a negative reaction and has tuberculosis is 2%, so 0.02. I also need to know the probability that someone has a positive test and doesn't have TB. Well, the probability that someone has a positive test and doesn't have TB, that's this false positive right here, that's 0.01. The probability that someone has a negative test and doesn't have TB, so TB converse, is 0.99. Okay, so I need to find the probability of TB and positive, and that's what we're going to find from our tree diagram. So let's go ahead and make a tree diagram. Cool. So my tree diagram, I have my first event that happens. There are two outcomes. They have TB or they do not have TB. Then we give them a test, and that test is either positive or negative. So our population that has TB is 0.0002. That does not have TB is 0.9998. If you have TB and you get a positive test, there's 0.98% chance. TB and a negative test, 0.02. If you don't have TB and you get a positive test, we found that was 0.01% chance of happening. And if you don't have TB and your test is negative, that's 0.99%. So if I want to find TB intersect positive, I'm going to be multiplying these together. So 0.0002 times 0.98 equals 0.000196. And this is the probability of TB and positive. Okay. This is 0.000004, 0.000998, and 989,802. Okay? So if I want to know the probability that someone has TB, given that they already have a positive test, that's going to be the probability of TB intersect positive over the probability of positive. Well, what's the probability of someone being positive? It's going to be this and this. So I have 0.000196 over 0.000196 plus 0.009998 equals, oh, so maybe I forgot a 9. There we go. That's going to be right about 0.02. So there's a 2% chance that someone has TB given that they got a positive test. And like I said, I do have the examples worked out for you guys so you can check your answers.